Okay, now we talk to symmetry vocabulary, uh, like configuration, identical configuration, and equivalent configuration, symmetry operation, and symmetry element. You can take a picture screen for this page. So now we have some symmetry elements and symbol and symmetry operation. Number one is identity, whole of space, symbol E, symmetry operation do nothing, mirror plane sigma, and symmetry operation is reflection, and proper rotation axis CNM, and symmetry operation is proper rotation. Okay, about CNM, CNM, like C1 1, C1 1, sorry, C2 1, C2 2, C3 1, C3 2, C3 3. Okay, what's C and what's N and what's M? Okay, N equal 2 pi over 2, 360 over 2 equal 180 degree. This is C2 when N equal 2. C3 equal 2 pi over 3, 360 over 3, 120 degree. And C4 90 degree, and maybe C6 60 degree. Okay, so now about C2 we make rotation by this angle, and C3, about C3 we make rotation about by this angle. And so like water molecule by C2, this is C2, rotation by 180 degree, 1 2 OH H2 1, rotation on the Z axis by C2. Okay, C3 take this example, boron trifluoride PF3 P F F F Sangers (120 degree), make C3 1, rotation by C3 1. This is number 1 2 3, boron trifluoride. This is 1 2 3, and C3 2, boron trifluoride, 1 2 3, and the last one, C rotation by C3 3, boron trifluoride, 1 2 3 at the same one. We can say C3 3 equal identity. Equal identity. Okay, what's identity? Identity leave any molecule unchanged. Like by identity 1 1 O H H 1 sorry 1 1 2 1 2 unchanged. Leave them unchanged. Okay, that's identity. Identity do nothing, unchangeable molecule. And proper rotation axis, we take now identity and proper rotation axis C and M. Okay, look at this example. Benzene. About C. For benzene we have C2 on the XZ on the Z axis. On the Z axis. This is C2 rotation by 180 degrees. This atom from this atom. Okay, this is C2. We have too much C2. Add C2, another C2. Another C2. Another C2. We have too much C2. And this is between two atoms. This is between two atoms. And between two atoms. And the last one. This is C2. Also we have C3. C3 on the Z axis. On the Z axis. This atom remove to this to place this atom. Look at. Yeah. Look at. Okay, and we have C6 60 on the Z axis. Here, this atom, remove to this atom. Okay, now we know about proper axis and identity. We take identity and proper axis C and M. Okay, what about sigma? What about sigma? We have three types for sigma. We have three types for sigma or mirror. Sigma, we have three types. Sigma phi and sigma d and sigma h. Sigma phi is a vertical mirror plane. A vertical mirror plane. Sigma d dihedral mirror plane. diagonal mirror plane, and this is between 2 sigma t, sigma d, between 2 c2, and sigma h is horizontal. Mirror plane, and perpendicular to the principal axis, and this is, and sigma perpendicular to principal axis. Okay, look at this example. Benzene. This is sigma v. We have 3 sigma v. We have 3 sigma v here, and 3 sigma d, and 1 sigma h. This is the last one, sigma v. Sigma v. This is mirror. This is 1. This is mirror 1. And this is for this. This is 1. This is sigma 1. Of course, this is sigma 2. Of course, this is sigma 3. And here we have sigma. And here we have sigma between atom. And here we have sigma. And on the plane we have sigma. You take all atom. You take all atom. Okay, look at me. This is sigma number 1. Sigma v. Sigma v is take z axis. And this is sigma 2. Sigma v, another one. And this is third sigma 3. We have 3 sigma 3. We have 3 sigma v. We have 3 sigma v. Okay, this is vertical mirror plane. Okay, what about sigma d? This is number 1. We talk about sigma t. This is dihedral mirror plane, or this is between 2 c2, between 2 c2. Must here c2, and here c2. Okay, look at. This is c2, and this is c2. This is sigma d, sigma d between 2 c2. Okay, another sigma d, another sigma d. This c2. Sorry, yes, this is 2c2. This is c2, and this is, look at, this is sigma d, and another one sigma between 2 c2, between 2 c2. This is sigma d. Okay, what about sigma h? Sigma h, it's a horizontal mirror plane, on the plane, on the plane. Look at me. Take all atom and perpendicular on the principal axis. What's the principal axis here? What is the principal axis in benzene? It is C6. C6. C6 is perpendicular for sigma, because this is sigma called sigma h. Is it clear? Okay. sigma h perpendicular for principal axis. Another element is improper rotation axis, or SN is equal C n and sigma h and sigma h. Rotate, you have two step rotate and reflection. Okay, S1 is equal C1 sigma h. Take this example. O H 1 2. Remember the three atoms not in the same level. Okay, not in the same level. C1 has identity, nothing, do nothing. O H H. Okay, C1 360 degrees. Okay, now we have a sigma. We have sigma between two atoms of hydrogen, and take oxygen atom here. This is sigma. Sigma and perpendicular for principal axis, this sigma h, and sigma h perpendicular for principal axis is S1. Take another example. Take another example. Okay, this S1 equal sigma h. Okay, we take another example for S2. S2 equal C2 sigma h. Take any example. A, B, 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 B. You must remember we have 5 atoms on the same level. On the same level. 1, 2, 3, 4. Okay. Now we have S2 and S4. Number 1, S2. On the z-axis, C2 on the z-axis, here. Okay, C2 on the z-axis. A, B, 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 B. 1 remove here on 3. This is 1, and here 3, and 2 here, and here is 4. This is C2. And sigma h, we have sigma h on the same level. Take 5 atoms on the same level. Okay, this is S2. Okay, sigma and perpendicular axis is sigma h. And when we take C4, A, B, 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 B. Okay? From here, this is 1, 2, 3, 4. C4 on the Z axis. Not forget. Don't forget. And sigma h on the same level given S4. Okay. Okay, the last symmetry operation is inversion. I is equal exactly S2. This is have two step. Rotate and reflect. Okay, we take example. We take any example. A. For example, F6. Look at me. This is 1, 2, 3, 4, 5 atoms on the same levels, and one is front and one is back. Okay, 1, 2, 3, 4, 5, 6. For element is I. This the first one makes C2. It's 2, C2 and sigma H. Okay. For C2, from here C2, one is coming in the place 6 atoms. Six and 1, 2, 3, 4, 5, and up. After sigma, take this molecule. Okay. 6 sigma here on the Z axis. Take 1 and 6 and A. Here 2 and 4 and here 5 and 3. This is the last one of symmetry operation. Okay, the last one in this chapter is determine a point group. Look at this structure. When a molecule is linear, when this molecule have inversion center is D infinity H or no C infinity H. When a molecule not linear, you go this way. When a molecule have XCN, when X over 2, when the answer yes, the point group is tetrahedral or octahedral. When the answer no, go this way. Half Cn, no. Half sigma, no. Half inversion, yes. Ci, no C1. Or when you have sigma, it's CS. Point group is CS. Okay. When the answer is yes, you can take this picture or take from net. This is available. Okay, thank you.